I try to share screen. Please send me a message. Do you see the screen of network computer, other computer with MATLAB? Okay, okay, thank you very much. Thank you. Yes, let's try to continue. Here you will see. Here you can see the code into the MATLAB, which creating the generative adversarial network GAN for producing new images from images of drying droplets. What does it mean? Generative adversarial network. It is a class of machine learning frameworks designed by Ian Goodfellow and his colleagues in 2014. What is it? Two neural networks contest with each other in a game in the form of a zero-sum game, where one agent gain is another agent's loss. Given a training set, this technique learns to generate new data with the same statistics as the training set. For example, a GAN trained on photographs can generate new photographs that look at least specifically authentic to human observers, having many realistic characteristics. So originality proposed as a form of generative model for unsupervised learning. GANs have also proven useful for semi-supervised learning, fully supervised learning, and reinforcement learning. The core idea of a GAN is based on the indirect training through the discriminator, which itself is also being updated dynamically. This basically means that the generator is not trained to minimize the distance to a specific image, but rather to fool the discriminator. This enables the model to learn in an unsupervised manner. The generative network generates candidates while discriminative network evaluates them. This is the main principle of GAN. Here you may see the code which producing this generative adversarial network. Here you may see we're using image folder with images of drops. Let's try to see into this folder. Inside this folder. Images drop. Yeah, here you may see all images of drying droplets which we can upload to this program. Here you may see drying droplets, drying drops, which from patients with tuberculosis. This is from patient with normal condition. This is from patient with problem with pregnancy. Here you may see tongue structure and more and more. This is our data set. It consists about 187 elements. We are using this part of code, this line image folder, for uploading this to the program. After that, we check for subfolders and uploading subfolders and images into the subfolders if it exists. After that, we are creating the variable augmenter and IMDs, which producing augmented image data store 64 by 64. After that, we are using filter size 5. It is for the filter which you can see later. After that, we creating layers of generator. Typically, the generative networks learns to the map from a latent space to a data distribution of interests, while the discriminative network distinguished candidates were produced by the generator from the true data distribution. The generative network training objective is to increase the error rate of the discriminative network. A known data set serves as the initial training data for the discriminator. Training, it involves presenting it with samples from the training data set until it achieves acceptable accuracy. The generator trains based on whether it succeeds in fooling the discriminator. Typically, the generator is seeded with randomized input that is sampled from a predefined latent space. Thereafter, candidates synthesized by the generator are evaluated by the discriminator. Independent backpropagation procedures are applied to both networks so that the generator produces better samples, while the discriminator becomes more skilled at flagging synthetic samples. When used for image generation, the generator is typically a deconvolutional neural network, and the discriminator is a convolutional neural network. And here you may see the layers of generator and discriminator. Here, the structure of the layers, as you can see here, you can find the ReLU layer, ReLU 1, ReLU 2, 3, and the hyperbolic tangents layer, and so some like this. Convolutional 2D layer, and so on. And here the layers of discriminator. ReLU, ReLU layers, convolutional 2D, and here you may see the batch normalization layer, for example, and so on. After that, we can tune parameters. For example, number of epochs, minimal batch size, learn rate, gradient decay factor, squared gradient decay factor, and so on. Flip factor, validation frequency. After that, we tune the parameters of this competition between discriminator and generator. And here, because we need to see the result, we are creating the plot. Plots where you can see the result of this of the application of GAN. Here the cycle from 1 to number of epochs, where we applying GAN to the data set. And here we are producing the new data set, which you can find, where you can find synthesized images. Okay, this is the quick review of this code. Of course, you can find it in the Moodle too. Today, I will upload everything what I produced yesterday and today, and you can find and download it. Yeah, and let's try to check how it works. Let's try to check how it works. Let's run this program in MATLAB. Yeah, and here you may see the number of iteration and score between discriminator and generator. As you can see, here, this is the red line, which show us information about discriminator, and here the generator. Let's try to check number of epochs. Now it's 20, and what is our parameters right now? Now our parameters 5,000 epochs, but we cannot wait a lot of time. But I want to show you the results between these values before 5,000. I want to see something when we have 100 epochs, for example. And here you may see the competition between generator and discriminator. As you can see, now we have generated images, but it consists not a lot of features, structures. You cannot understand that is it drop or is it something else. Need to wait more. And I want to say more about GAN. GANs often suffer from a mode collapse, where they fail to generalize properly, missing entire models from the input data. For example, a GAN trained on the MNIST dataset containing many samples of each digit might nevertheless timidly emit a subset of the digits from its output. Some researchers perceive the root problem to be a weak discriminative network that fails to notice that the pattern of omission, while others assign blame to a bad choice of objective function. Many solutions have been proposed. Convergence of GNs is an open problem. And in MATLAB, you can find the library which working with the GAN. It is deep learning library, and you can find here the library which library for the convolutional neural network, creating for the computer vision computer vision toolbox, for example. And of course, this library, this toolbox, toolboxes are not free, but we can buy this, and we bought it using MAGnUS program, using MAGnUS program budget. And thank you very much for the universities which are our partners for this support. And now we have libraries when we have a toolboxes for the good work with convolutional neural network, deep learning, AI, and computer vision. Let's check what's happening here. Yeah, you can see after 100 and after 100 epochs, we can see the changes into the generated images, and you may see the score of generator and discriminator stay closer to each other. It means now they have really hard competition, and it produces this result. Let's check after 200 epochs. Let's check after 200 epochs, and after that I will try to show you the final result, because I already got this result. Yeah, and now yeah, here you may see that you can download in MATLAB more packages which working with deep, which is deep network designer, which working with images. And what about libraries? Just 1 minute. Yeah, you can use this for downloading the toolbox, and you can use examples for deep learning toolbox. where you can find all examples how you may apply, how you can apply different and GAN to and other interesting examples which useful for the for work with deep learning algorithms. Okay, and here you may see the computer vision toolbox, and there are a lot of examples of computer vision toolbox. Okay, and let's check the result after. Yeah, you may see after 230 epochs, we have the images of drying droplets, but we cannot understand that it is drying droplets, drying drops. Need more time for understanding this. And I think I can show you the final result using my presentation. Just 1 minute. And after that, we try to come back to this calculation. Just 1 minute. I try to stop demonstration and okay. And let's check the result. Okay, I've tried to run presentation. Share screen, share presentation. Okay, here you may see my previous presentation, and this is the result after 7,471 epochs. You may see generated images. This is full how to say fake images because these images are not existing or doesn't exist. Why? Because it is creating from the real dataset using generative adversarial network. And as you can see, these images have many features, and we can understand that it is similar to these images, for example. It's like a noise image of this, noise version of this image. Okay, and here you may see closer, very similar to the initial image, and we can find some features on this image, like probably border, like this border, you may find it. And I think, yeah, I think it is similar. Why we need to use these images? As I said before, we have about 187 images in initial dataset. It isn't good. Why? Because for good training of neural network, for detection the structures into the images, we need to use the dataset which consists more than 10,000 images, for example. And one of the methods for creating this big data set is augmentation using GAN, using generative adversarial network. This is the reason why we use this. Another one method is applying my previous application with the Kinder, which I showed yesterday, for creating the black and white images, for creating images in the gray scale, or the in red, or creating with only cracks and bubbles without any features. If we can produce really big data set using these methods, we can train our detector with more efficiency. Let's check what's happening in our other PCs. Our PC. Share screen. MATLAB. Figure 1. Here you may see this is the result. It produces fake images. And you may see that it consists details with detalization, more detalization after 400 epochs. Okay, I think I try to explain more. If you have a question, please ask me and I try to answer. I'm waiting your questions. Okay, if you don't have a questions, we can continue after the coffee break with the lecture from Professor Patrick Merritt, University of Derby, UK. He will connect to us about 11:30 Astrakhan time. Dear participants, we are waiting for Professor Merit, and we can check our software in MATLAB if it is interesting for you. We can connect to the network PC and check the result of the gun. You may see here, this is interesting result of using gun, 1600 epochs. And you may see that now these images are have structures and many details. Let's wait probably more than 1 hour, and after the lectures from Professor Merit, we will try to check it again. Dear participants, we are waiting for Professor Merit from University of Derby with the lecture VR technologies in the healthcare. Just I tried to ask him for connecting to Zoom. To Zoom. Dear Patrick, do you hear us? Just 1 minute. Sorry for that. I'm trying to connect with Professor Merit from University of Derby, and I think he will connect to us after a few minutes. So sorry for this delay. Just I try to solve it. Dear participants, I don't understand what's is happening. Just now I am writing the email to the Professor Merit. Uh, I'm waiting the answer from him. Probably the problem with connection to Zoom or problem with the time zone. I tried to make something. Sorry for that. Just need to wait probably more. information for participants who have connected right now. We are waiting Professor Merit with his lecture VR technologies in healthcare. Now we try to connect with him. Please excuse us for this delay. Let's wait more. Probably he has a problem with connection. But I hope everything will be fine. More information for our participants, because now I see that we have already 58 participants. I send to the chat the link to our Moodle platform, and participants who want to get certificate of summer school, you need to you need to press to this link and need to make an activity in the Moodle platform. After that, I can check this activity, and we can write names of participants for creating certificate of summer school. Also, we can check the number and names of participants in our Zoom platform, and we try to check everything what you do in our summer school. Okay, now we have 58 participants. Let me check. I cannot see Patrick Merit. Just I try one more time. Don't forget that today we have another one lecture from Professor Sergio Rodriguez, Polytechnic Institute of Tamar, Portugal, after 2 p.m. Astrakhan Baku time. But now we are waiting Professor Mary. Victoria sent the message to the chat. Now I will send you login and password to the Moodle system. Victoria, I sent to you your login and password. Dear participant, sorry for this delay one more time. I think we need to wait 20 minutes more. Probably Professor uses Moscow time zone. I'm not sure. If it's possible, I want to ask you to make all photos. If it's possible for you, you can switch on your screen and we can make group photo for our website and for dissemination the information about MAGnUS summer school. If it possible, please switch on your cameras, or please place your image, your photo, because we try to make group photos, group screenshot right now. Let's try to do it. It is for the website of MAGnUS Summer School. Who can do it? Please. Now I see only my face. Please, let's make group photo. Okay. Yes, okay. Danila, please, I want to see you because you are very active user, very active participant of our summer school. Artem, please do it one more time after 1 minute, and we try to make group photo. Okay, Danila, Artem, Georgy. Who else? Oh, Georgy. Yeah, just wait a few minutes if someone else. Oh, Artem, thank you. We try to make photo right now. Who else? Oh, Vladimir, thank you very much. You need to see it. Oh, yes, good. Oh, okay, Victor, thank you very much. Danila, thank you very much. Yes, now I try to make one screenshot. Vladimir, yes. Rastyan, thank you for your participation. Danila, thank you very much. Thank you very much. Thank you, Pavel. Just I tried to make a group photo screenshot to our website. Who else? Who else? Thank you, Albert. Yeah, and I see photos. It's okay too. You can pick your photos to the black screen. Okay, thank you very much. I will try to make screenshot one more time. Yes, just say cheese. Okay. Yeah, good. Thank you very much. Please wait few minutes for Professor Merit. I don't understand why he cannot connect to us, but probably he will do it after the break, or maybe after 10 minutes. If he will do it after 10 minutes, if he uses Moscow time, I think he will connect after 10 minutes. If not, we are waiting Professor Sergio Rodriguez from Portugal after the break for the lunch. But now, please wait 10 minutes more for Professor Merit. Thank you for your connection. Thank you, Pavel.
Okay, you mute.
I saw a mail from Professor Merit. Dear Professor, do you hear us? Yeah, I see him. I see him. Dear Professor Merit.
Good morning.
Good morning. Good morning.
I do believe I'm supposed to be giving a presentation right now. I do genuinely apologize. I thought all the times that were on the sheet were in GMT. I'm sorry, I've just got up. Sincerely apologize.
I'm sorry too. Probably need to highlight this time in the program, because in the program you can find on the top of the program that current time zone Baku and Astrakhan, but sorry, probably need to highlight it. Thank you for your participation. Please, if you have presentation, you can share it.
Yes, I do. Just give me 2 minutes and I'll find it. Not too familiar with the Zoom. I was planning to turn up a few minutes early to sort everything out, and unfortunately that didn't happen. But give me 2 seconds.
The green button.
Yes, the share screen button. Got that. Yeah. Just got to move a few bits and pieces around and we'll find it. So screen 1. And there we go. Okay, so can everybody see the screen now? Yes.
We see your screen. Thank you very much. We see.
Excellent. So I'm just going to swap them over. So, whoops. Oh, well, that will do.
Yeah.
No, that won't do. Can't move the slides on. So there we go.
Yeah.
Right. So good morning, everybody. I apologize that I'm starting off late, but my name is Patrick Merritt. I'm here to talk to you about cross-reality in visualization in medicine. So just a little starter for who I am and exactly what it is that I do. My name's Patrick Merritt. I'm a lecturer in computer games, augmented and virtual reality at the University of Derby. And this is an example as to why you should never, ever let a man pick his own job title. So specifically what I look at is cross reality, which is, we'll get into a little bit as to exactly what that is in a minute. But basically I use AR and VR tech in weird and wonderful ways, specifically for the most part, use it to try and help people in some way. I take games technology and use it as a tool for rehabilitation and like teaching and learning and things like that, or the other way around, see if we can put use enhanced learning experiences using abstract games technology and things like that. I'd just like to start off with a little preface as to exactly what's going on here. First of all, before we start, I'm not a doctor. I don't have any medical qualifications or anything like that whatsoever. So please don't take anything that I present as medical opinion or anything like that, because I don't actually know anything about medicine. I don't know too much about healing people. I do know a little bit about CBT-based therapy and things like that, but I'm not a doctor. Please don't take me as one. But I do consult for integration of XR technologies into many high-risk scenarios. For example, installing AR technology in air traffic control towers and things like that. So I can analyze high-risk scenarios and see how the implementation of an XR technology may impact what's happening there. So, but medicine does represent a very interesting platform for integrating of XR, because there are a lot of different factors that go on within it, and there are a lot of different ways we could potentially implement XR within this environment, but we have to do so with great care, because there are like significant risks to what we're actually trying to do. So generally what the overview I'm trying to give you here is the overview of what might happen if you were to try and integrate these technologies into a medical environment, and what kind of things that we need to be looking out for when we're actually doing this. Okay, so I figured I'd start off with a couple of sort of terminologies just to describe what I'm talking about. And one of the first things you've probably heard me talking about a lot is a thing called XR. What is XR? Well, XR is basically the umbrella term that we use for determining all types of immersive display visualization. So this goes for VR headsets, AR mobile, cave setups, display walls, things like that. Basically any form of technology that alters the user's vision to display graphics on it in some way. Now there's two core branches of the technology we talk about, which are augmented reality and virtual reality. And if you've done any reading or you've looked around in the technologies in the past, you'll notice that there are a load of other sort of like terms like mixed reality and other ones split reality and things like that. These are specialized forms of augmented reality and virtual realities, and generally a hybrid between the two. But to keep things simple and not confuse everybody, we're going to just stick with the two major identities. Otherwise I'll be here all day just telling you what all the different terms actually mean within it. But if you know what these two terms mean, you can generally work out exactly what's going on within your situation and your technology. So let's start off by defining what virtual reality is. Virtual reality is where we take a user's perception of the existing real world and we completely replace it with a digital one, which means we isolate the user from the real world and completely give them another virtual world to actually interact with. Now, these virtual worlds may be based in reality. So for example, in our medical example, we could put somebody in a surgical ward, or we could put them in a doctor's surgery for training purposes, or we can make situations completely fictional. So we can have people walking on the moon, we can have people riding roller coasters from the comfort of their own home, and various things like that. So basically, we are taking the user and placing them in a completely different situation. The most common setup that you'll find with VR headsets nowadays is the 6 Degree of Freedom headset and the 6 Degree of Freedom motion controllers. So hand controllers and a headset. The headset provides stereoscopic vision via two displays that are set, one for the left eye, one for the right eye, and a set of lenses that alter the viewing angle of those displays in such a way that it creates a wide field of view within the headset. The 6th degree of freedom controllers basically are tracked in some form. We'll come on to that in a little bit. That basically allow the software to know exactly where those controllers are, and usually these are used to represent the hands of the user within the environment. With this, the user can pick up, push, pull, drag, interact with tools and all sorts of things within the environment, and it creates a system by where we have a visualization and a way of interacting with it. The controllers also have buttons on them for traditional video game style interaction, should they want to. Okay. There's 2 common forms by which we can actually perform the tracking for the headset and the handles. There's what is called the inside-out tracking method, which is the most common method of actually tracking headsets now. It's the prevalent one that's coming out within the industry, where all the cameras and things like that needed to monitor the position of the controllers and the headset within the environment are all based and mounted within the headset. So the headset will have several cameras and the controllers will have markers on them, IR markers traditionally, to actually track the position of these controllers within the environment so we can actually see them moving around. This represents a compact system because we don't actually need to build massive towers within the room. And also if the system goes beyond the boundaries of the track marker system, it will continue working. However, the other option with a system is to use what's called an outside-in system, where we have several cameras mounted around the environment, which actually monitor the position of all the objects within the environment that we're interested in tracking, and can use those to actually work out their position and feed those back to the computer. Like we say, the advantage of this system is generally you end up with a more accurate tracking position, but the disadvantages are that it limits the range and it also increases the costs significantly with doing this. So we generally try to use the inside out because it makes it a more compact system, but outside in is another option that we have. So how do we interact with VR systems? How do we actually look at and do things within a VR environment? Well, generally what we have is our motion controllers, which are taken to represent the hands, our hands in the environment. So the hands can be used to pick up things, point at things, touch things, interact with things, do things, and all sorts of things within the environment. You can pick up things and hold and manipulate them within the environment. What we don't tend to have is what's called fine motor control. We basically have the ability to clench and unclench our fist as we go along. And we can generally articulate with the fingers. We'll come back to this issue in a bit because it is actually quite an important issue when we're in, sorry, I lost my place. It's quite an important issue when we are interacting with XR environments that we understand the limitations of what we can do within the environment. While the hands are the most common way of interacting with the environment, we can swap these hands out for other specialized, more specialized pieces of equipment, such as we could have flight sticks if we were training somebody on a flight deck. If we wanted to train racing drivers, we can have racing wheels and pedals and things like that. So it's not the only option, but it is one of the most prevalent. It's not perfect. It's still in development. We're still working on this. Okay. Thinking about augmented reality, the difference between augmented reality and virtual reality is that in an augmented reality system, we supplement the user's existing view of the real world. We don't we don't replace the user's real world view. We add graphics to it. Now, whether these graphics are contextual to the real world themselves depends on what kind of systems you have to identify what's going on in the real world. For example, if you're using something like a HoloLens, you'll have a depth of field scan, which will let you know where things like table surfaces are and things like that. So you can place items on tables and locate things within the environment. Whereas if you're using something like a tablet-based AR system, you won't have that depth of field queue in most cases. So you just have to overlay based upon the information you can get from the cameras. The idea of an AR system isn't to replace the world, it is to supplement it. So it's the idea is to put extra information to get into the world to give some more information or context to the system. So this can be real information or it can be fictional information, but we'll just have a look at a couple of examples of that. So there's two main common branches of AR that we look at the minute. There's the headset AR, which is the super expensive, super secret things with the HoloLens and things like that. And the image on the right is an example of somebody using a HoloLens system. And the idea is that we have a turbine in front of the gentleman. And as you can see, a digital projection of the pieces that you go onto that turbine to reassemble it are placed in front of it. So he can see what those parts should look like. He can then go and acquire those parts, put them onto the machine, and it should assist him with completing that task. Okay, so the information is contextual. It shows him where the parts should go and what parts need to be where. Okay. So this is done by projecting, sorry, excuse me. This is done by having two small screens in the headset, which project light directly onto the retina of the user, who then sees the images as they are projected. Sorry, that was terrible. It sees the images as an overlay into the existing scene that he's looking at. Another common example is mobile AR, and we're going to go for the old chestnut of looking at the most common and most widely acknowledged version of AR, which is Pokemon Go. Mobile AR uses a camera to record a scene and then overlay graphics into it. So in this case, as you can see, we're taking a recording of a street and there's a Pikachu in the bicycle lane. Now, it's pretty obvious to everybody that Pikachu isn't actually sitting in a bike lane. A Pikachu would be much more responsible than that, probably would sit off in the grass and he'd probably find it much more comfortable. But in this case, we can see that there is a digital overlay of a Pokemon, a digital overlay of a Pokeball. And this allows us to interact with the scene because we can pick the Pokeball up, spin it around and move it. Now, how this works is that we have a camera that's recording the scene and the digital graphics are just pasted over the top of it, essentially. But if you'll notice, like I said, Pikachu is set in a bicycle lane. The camera has no context of what is actually going on in the world. We are just overlaying it into the scene. And if some of our walkers or runners would go over the top of the Pikachu, Pikachu would just be cemented over the top of it. So it's providing additional situational information, but it doesn't have any context of the real world. So just to summarize and recap before we move on, the different technologies that we're talking about here have different applications. We use AR when we want to supplement a real world with additional the real world with additional information. So we want to add something to the user's view. And when we want to completely replace the user's real world, we use a VR application. So if we want to completely take them out of the situation and put them somewhere else to do something so they can concentrate, we'll use a VR system for that. Okay, so we spent about 15 minutes talking about this, and probably the big question on a lot of people's minds is, what has this got to do with medicine? Well, medicine has been one of the biggest fields and that's like champions for using this kind of technology from the word go. There's been a lot of interest and investment in this from at least the 1970s when we started getting the first sort of like semi-usable XR systems. And there are a lot of problems with integrating XR into medicine, particularly prior to 2016, this was very expensive to do. But we'll talk about that in a second. But generally, what we want to do with it in medicine is integrate it into one of four streams. We want to look at doing clinical simulations, because if we can train a doctor to perform, say, for example, a surgery in a virtual OR, this saves us money, it saves us time, it allows more access to training, because you don't need to place a person in an actual operating theatre to allow them to run through the basics. So we can provide more access to training and better quality training. Data visualization, so taking a look at existing scans. There are several scans such as, I've forgotten the name of the scan, sort of like X-rays, and I'll come back to that in a second, that can be visualized in a 3D environment. So if you can visualize this, you can imagine being able to visualize the scan of a person, which normally would be viewed as a series of cross sections. And then imagine you could build those cross sections into a 3D model. You could then pick up the scan, move it around, look around it in different depth and cues, and will give you more information as to exactly what's going on within the person's body. Another way we want to utilize this is, sorry, did somebody say something?
Probably CT, computer tomography scanner.
Yes. Another way we can do data visualization is looking at contextual information access. So say, for example, you have a surgeon cutting a person up, you could have the idea of having marks for where that person might want to cut and things like that within the body. You could also provide access to a person's vital statistics while they're doing this in a convenient way, which at the minute is currently done via displays within the operating theatre, but displays are big and clunky and heavy and awkward to move around within that setting where space is at a premium. So if you could place it in such a way that the person can just get at it and put it wherever they want and access it within a glance, that would be a fantastic thing to do that. We can also use XR technologies for treatment, such as CBT exposure therapy. This is one of the big ones that has actually so far gone forward and actually been utilized within the environment. So there is currently a lot of exposure therapy, particularly for phobias and things like that, where they can actually expose a subject to a digital version of the stimuli while keeping them absolutely safe within the environment. So why has this become to prominence? Well, basically, we've just gone through what's called the XR revolution. Basically, in 2016, we saw the Oculus CV1 go on sale, and this represented a massive jump in the capabilities of VR systems. Before, your VR systems did exist, and we did have the ability to provide graphics and things like that, but they were always very limited in what they could actually do, primarily because we didn't actually have a technology that could go in the headset's display that was affordable and light enough to actually provide images of a reasonable quality. But to say that researchers went absolutely nuts when they found these things is a bit of an understatement. They literally, there is hundreds of thousands of research papers from this period where everybody grabs these things because they're now cost effective and available, and just starts doing all sorts of random stuff with it, a lot of it to do with medicine, particularly looking at the idea of providing the aforementioned solutions to the problem. The other thing we've actually got over the last 20 or so years is that smartphones are now powerful enough, and tablet computers are now powerful enough to actually do the mobile AR technologies. So we have access again to a platform that can actually do these technologies, and it's not rare, it's not expensive, and it's not going to break the bank if we buy these and distribute them to a large range of people. The problem we have at the minute is, because this is a relatively new technology, there's still a lot of design paradigms that we haven't actually figured out yet. One of the biggest ones we haven't actually figured out is locomotion. So walking around, moving within the environment. We still haven't actually got that down correctly yet. We'll come back and talk about that in a bit. But another one that we haven't got, which is particularly important for medicine, is keyboard interaction. We haven't got the ability to actually do data input properly yet. We can do it, but it's just very, very slow and very, very cumbersome to actually do within the environment. But again, we're going to come back and talk about those in a minute. So prior to 2016, we had 4 major limiting factors that prevented us from doing this in a really widespread manner. We had the bulk of the devices, which was basically everything was huge. All the systems that were needed to run them were massive and required just large amounts of dedicated space. It wasn't a case that we could pack this equipment up, take it to a patient's house and do an in-house treatment with it. Now we've reached the point where a solid VR system can be run from a laptop. And the equipment for it can be packed up into a case, a small case that will fit in a solid shopping bag. So we've fixed the bulk issue on this. Expense, because whenever a technology gets mass adopted, and we've not seen complete universal adaptation of VR technologies and XR technologies, there are more people using it than there were before. So now we can get some mass production going and we can reduce the cost that way. So we've got the point down to where we've got reasonable headsets for £300 on the UK market. I don't know what the equivalent of that is in local currencies, but if somebody could type that in chat, I'd be grateful. But we've got the expense down to where it's reasonable now, and with more adoption, there will be more cost savings to be made here. An important one, though, is accuracy. And what we're talking about accuracy here isn't so much the tracking of hands and things like that. We can allow for a little bit of a differentiation in that in most circumstances. What we're talking about is the accuracy of the graphics. Prior to 2016, we didn't really have the flat panel LCD displays that we needed to make this work, or the OLED displays, or whatever technology it is that you're using at the minute. We couldn't get the technology small enough and light enough to put in front of the user in such a way that it would provide an image that was of suitable quality to be believable. And that's the important part. One of the key challenges of a VR environment is that we have to convince the user of the technology that they're no longer in their existing environment. The aim is to replace it. This has led to other problems. We'll again address those later on in the presentation, but we now have it sufficient. Now, it's not, the graphics are not the same quality as you would get from a top-end PC, and it does still require something with a little bit of graphics punch to run it, but it's comparable. It's not, we're not talking like it's sort of like, for want of a better word, PlayStation 1 era graphics where we have sort of like box shapes that represent things. We can now actually create a fairly realistic looking human in these environments and display it to the user. And the final point we have is availability. These devices, they're not common, but they're not rare either. You probably know somebody in your friendship circle who's bought one of these devices and has got it in their house and used it for all sorts of things. And they do exist, and getting hold of them isn't exactly a difficult prospect if you wanted to develop for them. And when it comes to mobile AR capable devices, they're extremely common. Basically, 80% of people probably have a mobile AR capable device on their person in the form of their mobile phone or a tablet around the house. So it's becoming a more expected thing that you can expect that somebody will be able to run this. So what I figured we'd do at this point is just to take a look at a couple of examples of where this technology can actually be used in a medical setting. So I've got a couple of videos I'd like to show. The first one is from a piece of software called Medical Holodeck, which reiterates the point I was making about being able to view scans and medical scans in 3D and plan things within the environment. So there we go. So as we can see in the video, this is an example of being able to pick up and manipulate a 3D scan and be able to plan, I believe it's the abscessing of the removal of a lesion within the skull. And it allows the person who's viewing these scans to actually look at it in much more detail and be able to actually pick it up and look at it from all perspectives within the image, which you couldn't do with a traditional scan-based system. You would be able to look at it in vertical slice by vertical slice, but you wouldn't be able to just pick it up and rotate it freely. So we can get a much clearer idea of what's going on in a much quicker manner within the system. And this represents a potential for data visualization. Whether this is actually being used in hospitals or not at this time, I'm not entirely certain. I couldn't find an example of where it is being used, but it does represent a future for where we could go within the future. Sorry. The second video I have to show you is an example of actual treatment, of actual therapy being used through the Oxford VR system, where they actually look at using this for exposure therapy, in this case, social anxiety and things like that. The video doesn't have any sound, I believe, while I'm playing it, but there are subtitles, so you'll be able to know what's being said in the video. I have got links to these videos at the end of the presentation, by the way, should you want to watch them with sound. Okay, so that's another example of how you can actually use VR in a clinical context and actually treating patients for social anxiety and things like that. As you can see, it allows them to experience everyday situations in a controlled manner and allows them to actually rehearse going through those examples. The key thing here is that this therapy doesn't work if you don't believe the environment, hence why we need to get the graphical quality up to a certain level where the actual actors within the environment become believable. All the factors that we've mentioned before are important to being able to deliver this. As you can notice, the technology is delivered via a laptop, so it can be portable and it can be taken to a patient's house, and therefore they can be given the headset for a period of time for which to practice their therapy in a comfortable environment for them. Okay, so a lot of the point is, why should anybody in the audience who is a developer actually care about XR? We've been doing development for years, and what's the issue here? Well, adoption of these technologies is becoming much more widespread. We're seeing it in many, many different fields, from the main ones that are adopting it at the minute are the video games industry, and construction and architecture, also massive purveyors of this, and are already using this to good effect to actually visualize buildings for customers before they actually put them up, so they can see exactly what it is they're getting. And this is only coming out into more industries as we're sort of developing the technologies. More places are beginning to find them more and more useful, particularly for their health and safety training, because they can actually put people through the training and not only show that they know what they need to do in certain situations, but they can actually do it and do it correctly as well. And so therefore the likelihood that you're going to encounter one of these devices in your workflow is increasing significantly. It's more likely that somebody's going to come to you and goes, hey, we want an XR system. We want to, say, build a virtual reality version of this lab so we can train new inductees or things like that. So this technology is becoming more and more commonplace within the working environment. So you need to understand the differences between developing for an XR system and the issues with developing for an XR system compared to your traditional desktop. Most of these issues relate to how we do things and where we place them. But actually understanding these issues can give you a bit of an edge when it comes to actually putting these systems into your workflow, and can actually make it more likely that they will be successful when you integrate them. So what are the challenges for implementing XR technologies into modern healthcare? Well, the first challenge we've got is that your traditional UI paradigms don't actually work too well. So the idea of drop-down menus, combo boxes, text input fields and things like that, you can do that. You can place it on a flat surface within the environment and then have the user actually physically interact with them. However, these tend to not work too well because they actually need to be near the user and they actually have to reach out and touch them and things like that. And because we don't have the traditional methods like the keyboard and the mouse available to us in most situations, these data input methods tend to be very clunky and clumsy and very fiddly to actually work with, and people just don't like them. Many attempts are going on at making the virtual keyboard and the virtual mouse for use in VR. We haven't cracked this problem yet. We have several people actually working on and researching this at the minute, and we're waiting for our breakthrough moment. We're waiting for the software equivalent of inventing the keyboard and mouse to actually give us a decent interaction method for these technologies. The other problem you have with developing these interfaces is it's not just a flat screen that you're developing for. When you're actually developing, sort of like for, say you were developing a word processor application, it's flat screen. You can lay out all the areas of your screen with exactly what you want on those and what tasks you want to go where. With a VR environment, it becomes a lot more, and a VR or AR environment, for example, it becomes more about not just what to put down on the screen, but also where do you put this within the environment. We need to think more about how our UI elements actually get positioned within the environment. We're talking about the difference between diegetic UI elements and spatial UI elements for the most part. But I've probably just used two terms that nobody actually understands within the environment. So I'm going to just quickly go over what those actually mean. There's four core, when from a game's perspective, is the easiest way to describe how these work. There are four common core UI element types within so like virtual environments. We have the diegetic UI, which is the preferred way to do this, which is that the UI element has a physical place within the game world. So i.e. it actually has a place within the environment. So it's placed somewhere in the virtual environment so you can get at the information. And it also is incorporated into the fantasy of that world. Now, the term fantasy in this case doesn't mean that it's every virtual reality world is make-believe and has some weird situation where we have to create a sort of like brand new lore and everything for a world. When we talk about fantasy, what we're saying is, does it integrate itself with what the environment is trying to represent? So does it, for example, if we look at this example that we've got in the top left corner, this is taken from a game called Dead Space. And there are two glowing meters on the back of the character. One represents the health meter, one represents the status meter. Now, they are diegetic UI elements simply because they actually have a position in the game world. They are attached to the back of the character, and they incorporate into the fantasy because they are integrated into the suit of the character. So so they are both incorporated in a physical place and into the fantasy, and therefore they are diegetic. There's non-diegetic UI, which is the complete opposite. They have absolutely no place in the environment or its fantasy. Now, this is the most common UI element that you can encounter day to day in a traditional 2D environment. And the example of this is if you look at the bottom left, we've got this text box. And this text box has no place within the environment. It is just slapped straight as a 2D UI element straight onto the view that the user is looking through, and there is text on there. There's no intent to incorporate it into the fantasy of the game world. It's not a control panel. It's not a display on a screen within the environment. It is just stuck there. Now, you can see possibly the problem with doing this in a VR or XR environment is if we just have a floating display in front of us, this is very difficult to actually work with because it gets in the way and we can't see what's behind it. So generally, we'd have to at least turn it into a spatial UI. Now, a spatial UI element has a physical place within the digital environment, but doesn't incorporate itself into the fantasy. Now, the example that we give in this is if we look at there's two examples in this image in the bottom left. There are several cars on the racetrack, and some of them have a floating name and number above them. Now, these are spatial UI elements because there's no way that that is realistic within this within this environment. People don't have giant floating name tags and numbers above them in real life. So it's not integrated into the fantasy of this world. However, it is integrated into a physical place. It tracks and follows where the car is within the environment. The other example is the more common one that most people are familiar with, is the idea of a sat-nav. The sat-nav can actually broadcast a sort of like optimal line for a path or a track through an environment. And as you can see that in the racing line that's broadcast on the road. Again, this is a digital representation, a digital overlay into a real world scenario. There's no way that could actually happen in real life. However, it is integrated into the place, but not the fantasy. The final one, which I strongly advise you never, ever use in a medical scenario, would be the meta UI. And this is the opposite of a spatial UI. It's where it has no physical place within the environment, but it does incorporate its fantasy. And the most common example of this is when you get shot in a video game and you end up with the big red strawberry jam mist coming in from the outside. The strawberry jam has no place in the digital environment. It's attached to your face. However, it is attached to the fantasy because it's designed to make you believe the character is injured and the character is bleeding. Okay, obviously, this is not a good thing to actually implement into a medical scenario because we don't actually want to shock our surgeons into believing our patient's injured or worse, injured themselves. So we try to avoid that. Okay, so recapping on this and thinking about how we do this, let's look at a practical scenario for this. So as a scenario, as developers, we've been tasked with creating a system for a hospital that displays a virtual name for a patient. The target platform we're going to use is the HoloLens. So it's a pass-through XR system. So essentially a pair of glasses that we wear that allows us to place a digital overlay into the real world scene. And it's going to be used throughout the hospital by basically all hospital staff. And let's assume that we have no problems with tracking where a person is. Where do we put that nameplate? into the scene. And this isn't as easy as you think it is, because a lot of people would be like, well, let's just go with a traditional video game model and put a floating label above people's heads. Okay, this is problematic simply because people are of different heights and things like that. So when we end up in a situation where we've got a floating name above a head, anybody who's really, really short looking at somebody who's really, really tall in a close-up scenario is immediately going to end up craning their neck upwards to look at the name tag and have to constantly do that. And that's going to cause fatigue and stress on the neck, which is something that we try to avoid doing. We try to put our graphics in a comfortable viewing angle for the user. So let's go for the traditional name tag. Let's put it on the chest and things like that. Now, in a medical scenario, this isn't a great idea either, simply because what if our injury or the part of the patient we need to work on is below that name tag? It's now going to be obscuring what we're trying to do. And if we're in an ER emergency situation, that's obviously going to be a big problem. We'd need to get that out of the way. Another suggestion would be to make it contextual and have it float around the user in a dynamic way, so it's always off to the side. But then it becomes a case of, how do we look for this information? We can't get it at a instantaneous glance because we don't know where it's going to be. It moves around all the time. And while that might not be such a big problem for a name, we've probably got enough time to look around to find a name. But what if we were trying to put some sort of like patient data on there, like blood pressure or something like that, something that we might need at an immediate glance at some point? That's going to be difficult. We need to know where the information is. So there's no perfect answers here. There's no one right answer, but we have to consider, whenever we put something into the environment, we have to consider where we're putting it and why we're putting it there. Additionally, while we're tracking people, we might not necessarily be tracking the position that they're in. So depending upon how we're tracking the person, different postures and positions may impact where our information appears. For example, if we assume that all humans are standing up, when they lie down, they're going to float images just above the head, and it's going to be harder to deal with. It's not going to be in the same place. Slouching and things like that, and different postures can affect basically where our graphics end up if we have them relational to the person. So we have to, we're not just, we've now transitioned from the difference between the traditional UI, where we know where the screen is, we know where all the UI elements are going to be if we put them down. We're now looking at a situation where we're going to have to put something into an environment and we don't have entire control over where it's going to be within the environment. So we have to think about all these different situations when we're putting this information into the environment. Another challenge with your XR environment is that generally we don't, like I say, I've already alluded to this, is we don't have access to traditional UI interaction elements, our common ones of being our keyboard and mouse. What we generally have is the ability to pick up, push, drop, throw, pull, and move and manipulate objects within the environment using the hand controls. The one thing that hand controls don't really do too well is fine motion control. And I believe at this point, an example is useful. I was hoping to have a video of me running at the same time, but if you have a biro on your desk, if you pick that up and try and write something with it, that's an example of fine motor control. We require fine motor control in our fingertips to manipulate the pen into the correct position. And if we want to just depress the button on the top of the pen to retract the nib of the pen, we need to move our hand into a sort of fist-like motion and then use our thumb to manipulate the top of the pen. Current VR motion control systems don't do this very well. At best, generally the best we get at the minute is the ability to manipulate each finger individually and the thumb individually by opening and closing those fingers and those thumbs. We don't get fine control, which in a medical situation where you're trying to teach somebody, say, surgery and you want them to make an incision, this is going to be difficult because they're not going to be holding the tool that they're using in exactly the same way. So in this case, VR is a enhancement to existing training, but it can never be a substitute at the minute because we don't have that fine motion control. The other problem you have is that you have no sense of touch within the environment. So when you pick something up, you're not actually feeling an object. You don't get a feeling for it. Now, this isn't as big a problem with the VR systems with the motion control because you're pulling a control or pulling a switch, so you know you're holding on to it. But most like AR systems and some VR systems now are beginning to go towards hand tracking to get back some of the dexterity and fine motor control into the situation, which is fine. But if you pick up an item, you're not entirely sure whether you've actually managed, you aren't holding the item. Generally, you're pinching. So you're pinching to hold yourself. So you're pinching through the object and picking it up and manipulating it. So you don't get a sense of touch. So again, you can't just entirely rely on these systems to train somebody in these cases because you're not doing the same actions. There still needs to be a case where they actually go in and do it. So you could learn the processes, but not actually learn the activity at the minute. The hand tracking does seem to be a way of getting around this, and it is becoming more and more prominent in like all forms of XR. But it's still not 100% reliable, so we don't rely on it as a usable technology. But I imagine that most systems will change over to something similar like this within the next like 5 years or so. Another supplemental control to your XR systems is your voice controls. Now, these represent a significant problem in a medical environment because while they are they are very commonly integrated into AR solutions and VR solutions now. They're very, very useful when they work, but I imagine that everybody has interacted with Siri or everybody has interacted with Google at some point in their life. And how many times have you asked Google a question or Siri a question and Siri has given you a completely and utterly gumph answer that you don't really understand? Even with simple instructions, this can go wrong. I'm just going to show my nerdiness off here. I have a Google smartphone by the side of me. You probably won't be able to hear it, but if I ask it to roll me a D20, so ask it to roll me a 20-sided dice so I can go play Dungeons and Dragons, it will do that quite handily. But another one of the common examples of things that I'll ask it to do is roll a D20 and add 6 to it. And what that will result in is Google rolling 6 dice instead of that. When in reality, what I'm asking it to do is roll the dice and add 6 to the result. So it can't understand fully these complex instructions. It can only work with what we've programmed it to do. Now, we can program it with these complex instructions, but each one requires specific integration for it to actually work. It does work best with simple commands. But the other issue you've got in a medical scenario, if you're treating a patient and using the XR system, is you've got the privacy and legal issues, the GDPR and CISPA. So if, for example, a convoluted example, imagine if your doctor is treating you and you've got some embarrassing condition like piles or something like that, and you hear the doctor say, book Mr. Jones a appointment for his pile to re-examine his piles on Thursday next week. You might not be too happy about that if your doctor can be overheard by other people or things like that. So you have to think about these things. We'll come back to these legal issues in a bit. I do have an entire slide dedicated to this, so we'll talk about that in a minute, but we're not done there. We're coming back to that. But the biggest issue we have with these devices, the single biggest issue, in my opinion, is the idea of safety, being safety critical. Now, to define what a safety critical system is, a safety critical system is a system by where its failure results in death or serious harm to a person. Okay, it also can refer to serious damage to property and other things like that. And it doesn't just refer to the user, it refers to anybody involved in the system. So in our case for our medical scenario, we're not just talking about the doctor, we're talking about the patient, we're talking about the porters, we're talking about visitors to the hospital, we're talking about everybody, all the stakeholders that are involved in this system. And medical systems do represent a system where everything needs to be treated as a safety critical system, because in most cases in patient care, especially if you're in direct treatment, you can't afford these systems to fail. Even in your database back-end systems, you can't really afford for failures there because you lose information and you lose diagnosis information. You're going to have to go back and redo all these diagnoses, and that's going to cost time and resources that you just don't have, and therefore somebody is going to receive inadequate care. Also, if the care is time sensitive, such as a cancer scan, a scan for determining if somebody has cancer, then you might, by delaying that, you may cost somebody an opportunity for an easier surgical option to a more complicated one. The condition may develop in the time that you're dealing with it. So these systems have to work first time and have to work every time. So I put together a couple of scenarios that I'd like to talk about, just to sort of give you an idea of what we're actually talking about here. So we have a patient that's being treated for arachnophobia using a VR exposure therapy. This is actually a thing that goes on at the minute. This is an existing treatment that you can actually get in medical practices. I'm not sure if it's available on the NHS, but you can opt for this kind of treatment. And while this user is in the therapy, in the treatment, the cable connecting the PC and the headset brushes the user's arm, which could be interpreted as, say, the spider running up and down the person's arm. What's the possible harm to the user from this? Well, you've told them this is a nice, safe space, and nobody's going to touch them, and it's going to expose them to the idea of having a spider around them, and then you go and run something on their arm that could be, especially in their heightened sensitivity of the user, interpreted as a spider. Have you just made this person's condition worse? Entirely possible that you've actually just done some psychological damage to the user. So you have to think about it. This is one of those scenarios where you have to actually think about what you're doing with the equipment, but also how it's set up. Let's also look at another scenario in this situation where the cable connecting the PC and the headset is severed, resulting in a display that just terminates, just goes full black, nothing showing on the screen. What's the fallout from this? In an agoraphobia, in somebody with arachnophobia, this is probably bad, but not terrible, because it's just failed, and you could explain to them that it's failed. It might cause some damage there, so we need to be aware of the fact that it's there, but it's not anything that's directly related to the condition that we're treating at the time. So it's not as bad. It's still bad, but not as bad. But let's consider these two scenarios if we're treating something different. If we're treating a cluophobia, I didn't bother to tell you what arachnophobia means, because I'm assuming everybody understands that arachnophobia is a fear of spiders. A cluophobia is one that's not as well known, which is a fear of the dark. Okay, so let's look at our two scenarios again and now look at them with this. So the cable brushing the user's arm, and you're putting them in a dark situation. That again is going to be pretty bad, because again, somebody being touched while they're using something that they're exposed to when they're being exposed to something they're frightened of is generally going to freak them out. We don't want to do that. So we have to make sure that our cables are away from the user. But the second scenario, where the cable connecting the PC just cuts out the vision to the user, that's a big thing, because what you've done essentially is just plunge this user into full darkness, the very thing that they're absolutely terrified of. So you have just exposed them to the thing that they are unbelievably scared of. So this is a complete and utter ethical violation. So we would have to make sure that in our system, if we were going to treat somebody with a cluophobia, we would have to make sure in our system that this could never happen. This is an unacceptable situation. Whereas it might be slightly acceptable in an arachnophobia situation, depending upon how serious you want to take your ethical guidelines on this. Depending on the treatment, you have to look at different aspects of the device to make sure that you're not doing anything that puts the user at risk. In both of these cases, it's psychological damage. At the end of the day, we didn't kill anybody, and we didn't actually kill anybody. Well, let's look at a situation where that could happen. So we've got a surgeon using an XR headset to provide information to him during an operation. Now, this isn't actually being done at the minute because the systems are definitely not reliable enough. It's a pipe dream, and it's been a pipe dream of the medical industry since AR became a thing. But let's say that during the operation, there's an error with the software, and it causes the display to show a uniform red color across the entire display. What's the fallout from this? Well, red being the color of blood, this is a particularly poor color to choose to put across the screen, but the impact will largely depend upon how saturated the color is. If the color is saturated to sort of like a 20% level, so it's a red tint to the user's entire vision, you might not think this would be too bad. They can still see, and they can still see what they're doing. However, adding that red color across everything reduces the visual contrast of everything else that they're looking at. And there's a lot of red colors inside the human body that you'd need to look at, and you need to be able to differentiate between different parts of the body at different points. Adding red to that scenario is going to make it more difficult to differentiate. So we've just made the guy's job much more harder with this. but he could potentially still carry on if he needed to, but it would be much more difficult. He would probably need to get some of the observing assistants to take over at this point. Worst case scenario is the full red color is completely saturated onto his view and completely replaces his view. So all he can see is red. At this point, you've effectively blindfolded a man while he's doing a surgical procedure. And I don't know about you, I wouldn't be terribly comfortable with that. I wouldn't be terribly comfortable with that if there was even the remotest possibility that could happen. At this point, it doesn't matter what color it is. You've effectively made him blind. So how do we resolve this? If it did happen, what the response would be? And if it's anything like air traffic control, which I do have some experience in, I can tell you the response of the surgeon is going to be to take the device and rip it off his head and throw it across the room, which obviously we don't want him to do, because these devices, while they're available and they are reasonably priced, they're not exactly cheap. A HoloLens will set you back about, I think it is 1,500 quid at the minute, which is not a small amount of money that we have to deal with. But the backup is he takes the device off, but that in itself is a problem, because we can't guarantee he can take the device off easily. Imagine if he's got other things on his head, like, for example, he's using a headset radio or something like that. He's got a light attached to his head. I know that's a very antiquated view of medicine, but it is a possibility. He might decide he wants something on his head. What if he's wearing glasses when he takes those off? What happens if his glasses go with it by accident? Again, we need to make sure that in the case where our device fails, that we have a backup plan to remove it. Ideally, we make it so that our device doesn't fail in the first place, but we can. There is never a scenario where we can 100% guarantee that that our device is never going to go wrong. But we need to try and make them fail safe. So the idea would be that if there was a failure, the idea was immediately you would remove all the graphics from the user's view. So you're never going to be left in a situation where you're leaving residual graphics on the screen in the event of a failure. But you need to account for the fact that things do go wrong. And when they do go wrong, you need to have a backup, and you need to be able to make sure that you're making people safe. Okay. So getting towards the end now, let's look at data protection. So we have the same responsibilities for data protection for, like we mentioned GDPR and CISPA earlier, for XR systems. But the XR system itself introduces additional problems with this. Some of them are obvious and some of them are not so obvious. The obvious ones are voice commands that can be overheard by users within the environment. So we already mentioned the example of people being told they've got piles and things like that. We don't want to tell them that in a public setting to record that information into the system. But the other problems you've got are that gestures that you're performing can be interpreted. And one of the common ways of doing a keyboard at the minute in an XR system is to actually just present an array of buttons and have the user poke at them with the controllers or things like that. Now, if somebody's observing this or recording this via some sort of CCTV, if they know the keyboard you're using and they know the layout of it, if they watch carefully enough, they can actually extract the data from this by just your gestures, because they know what you're doing, they know where your gestures are aimed, and they can work out exactly where they're going to hit on the keyboard. And so therefore they can skim and steal that data. So it's not something that's going to be incredibly common, but if somebody were determined enough, they could do this. So we have to think about that. And generally, if you were concerned about that, one of the ways you could get around that would be to reposition the keyboard slightly during each iteration and each run of it, which would prevent this issue, because you wouldn't know exactly where the keyboard was each time. It would go some way to mitigating it. However, it would also make usability of the keyboard more difficult, because you couldn't learn muscle memory to interact with it, because you wouldn't be able to instantly know where the E key is. Anybody who touch types rely on the fact that when they put their hands on the keyboard, as long as they can anchor their hands in the same place each time, they'll be able to touch type with familiarity and be able to actually type the information they need to into the keyboard. If you move the keyboard around each time, it makes that process much more difficult in acquiring the base position of the keyboard each time. You have to move your hands around and find where your central keys are and then work from there. Same thing goes with the XR systems. The other thing you've got projected data that can be viewed by others. Now, that's obvious in mobile XR, where you've got a tablet, which is being used to view information in the world. it's sort of using a camera to create an overlay, somebody can be just skimming that information from you from behind. It's not so obvious though when we're talking about headset XR, because headset XR is broadcasting the image directly into your eye. So how is somebody interpreting that? Well, depending upon the system, it can be possible to actually see the image that's being projected on the lens. So it depends on the system, but you can actually record the lens of somebody and be able to get a lower resolution version of that image back. Again, this is like conspiracy theory. Oh my God, why would you do that? Well, it can happen, and people, depending on how desperate somebody wants to get the information, I imagine that a paparazzi, for example, might be very interested in the medical conditions of a certain celebrity and things like that. So we do have to be aware that we have more data protection issues and more access points here. I'm sorry, I'm running over. I'll probably be about another 5 minutes if everybody's okay with that. The other issue you've got with this is that most XR systems use some form of camera for tracking, and in a medical environment, people generally don't want to be recorded. These cameras aren't necessarily recording physical images. They might be recording IR within the system, but having a camera there might be unsettling to your patients and things like that. So again, you need to consider the impact of what you're doing on your patients. Looking at image quality, basically, when we use displays, we're looking at this more from the diagnostic work rather than the actual display, because for the most part, when we look at images on a computer screen, for the most part of what we're doing, images, when we're looking at it, a reasonable quality is fine for most people. We don't notice a subtle change in a green color or a red color within the image, for example. When we're doing diagnostic work, however, this becomes majorly important. Subtle changes in color can have a massive impact on the information that's conveyed within the image. I don't know if how familiar people are with diagnostic imaging within the audience. I imagine there are certain people, but when we look at displays from images, we calibrate them not for optimal image quality, we calibrate them for consistency of the image being projected. So the image being projected has a consistent amount of information with all the other devices that we are going to look at that image on. So the tablet computer that you're viewing the image on, which is calibrated to the same to the desktop, so they can see the same amount of resolvable detail within the image. And generally, image displays used for diagnostic work actually use higher quality displays with a higher bit rate. So we end up with 10-bit displays rather than 8-bit displays, which allows for a higher range of colors and more fidelity within the image. But with an XR system, this is much more difficult to control. For a start, we're using 2 different displays at the same time. So we have to make sure that those images, those displays actually, when they interact with each other, actually produce an image that is of a reasonable quality, that's of the expected quality. So the expected information can come across from it in an accurate manner. But the biggest problem you've got by far is the environmental conditions, because with a diagnostic display with a PC setup, it's going to be in the same place each day. It's going to be in the same environmental conditions. It's going to be in the same lighting environment. And so therefore calibrating it is a lot easier. With an XR system, these displays move around and are portable and operate in a wide range of environments. Looking at an example again that I've put together for this, recently we've started issuing ambulance crews with tablets in the back of them. So they got access to patient records in the field. With this, though, the biggest problem we've got is we've got massive changes in environmental illuminance, the amount of light that's in the environment. And I don't know if you've ever been at the pub in the summertime or wherever, or out socially in the summertime, and you've been trying to use your mobile phone, and it's so sunny outside that all the light reflecting off the mobile phone means it's impossible or very hard to read what's on the screen. It's much harder. Ambulance crews are going to be dealing with that kind of thing all the time in different ways. And their illuminance profile changes massively across the time of because they work long hours. They work for a huge range of days, and they work in different conditions. They work at daytime, nighttime, and they work in low light conditions, high light conditions in internal buildings. But also you've got things like the flashing lights from the ambulance, which are constantly changing the illuminance profile, which is going to interfere with that. And you need to look at these things when you're doing it. Now, I'm not suggesting that ambulance crews are looking at medical scans and making diagnostic issues here. Sorry, diagnostic decisions here. What I'm suggesting is that they are trying to extract information from a system, and the illuminance in the environment will make it more difficult to do that, especially if it's high or low luminance conditions. Admittedly, high luminance conditions are going to be worse than low ones, because we can always turn the brightness down of a display to make it more comfortable to view. There will be a finite point at which we can actually turn the brightness up to accommodate for illuminance within the environment. The other thing is that we're going to have inconsistent viewing angles of the display. We're going to have it at different angles depending upon how the user is holding it. And therefore, this can impact the information that's coming across depending upon the viewing angle of the display. This isn't so much of a problem nowadays, as most tablet displays have very, very wide viewing angles before the image starts degrading and breaking down, but it is still something we need to consider. I think this is my final point, but we'll try and make it, and then we'll see if it is, because I can't see the next slide. Traditional, we're looking at health and safety, the old chestnut that nobody else wants to ever talk about it. Traditional VDU health and safety law does apply to XR technologies. So you have to take significant breaks from it and do other things for every 5 minutes, every hour, which we also know that nobody observes and nobody does in practice, but you should do. It's even more important with XR displays because they do actually put strain on your eyes because of what's called the divergence accommodation conflict issue, whereas you are trying to look at a image that is projected as being a certain distance away. However, the actual display is only a certain is a fixed distance away, which means the two systems used in your eyes to actually work out how far something is away are in conflict as to how far that object is away, causing eye strain and fatigue. So it's even more important to pay attention to these breaks and things while we're using the XR technologies. However, XR technologies also require a lot more space to operate within. As you can see, generally you move around within the technology. AR technologies essentially are worldwide space. We move around, we do all sorts of things with them, and the range is potentially unlimited. VR systems are limited by their tracking mechanisms, but you could theoretically have a VR play space that is as wide as the space you have available. But the difficulty we have here is in all cases, we're interfering with the subject's sight. In the case of VR, we're completely replacing their eyesight with a non-physical world, sorry, a digital world, a digital environment. And as such, we have to make sure that while they're using this, we protect them from other people wandering into the area. Motion controls being swung around and getting hit in the face hurts. Trust me, I've had this happen on more than one occasion while I've been testing things. It sucks. Don't wander into the play space of somebody who's doing this, but we basically have to give them a dedicated space and make sure that they're safe within that space. Now, early VR systems didn't make any sort of accommodation for this, but the new ones now, we generally have something like a guardian system where we draw a digital fence around the outside of the play space to stop the user wandering outside of it. However, the user can't stop people wandering into the play space because they just can't see them. They can hear them, but you have to be aware that this is an issue while you're actually using this device. Also, because they're blind, they're trips and falls and things like that. They can't see what's in the environment, so you have to make sure that the environment is clear and safe for them to use. In XR, it's not as obvious what the problem is. There is a similar problem, but when you place a graphic on the screen, you're effectively occluding the user's vision from what's behind it. You're at least obstructing it partially, which might not seem like a big problem, but if you, so for example, you've got your porter who is moving a patient from one ward to another in a hospital. And we've implemented a system like a sat-nav, which places a marker on the floor that tells him where to go. So he knows exactly where he's got to take this patient, and you can just follow the marker. We put the marker on the floor and it covers up a spill on the floor. And he doesn't see this. He goes into it, slips, trips, and falls because he's not prepared for it. What caused that issue? Well, it's obviously the XR system covering up the hazard so he couldn't see it and therefore was not warned of it and had no time to avoid it or do something like that about it. So we have to think, how are our users going to be affected again by the graphics that we're putting into the scene? I'm going to skip this slide. I was just going to point out that there's a trailing cable here, but I think I mentioned that already. The final issue that we're talking about, this is the final issue that I'm definitely got to the final issue at this point. Cyber sickness is a problem with all XR devices. And basically what cyber sickness is a form, it's not motion sickness, but it presents exactly the same as motion sickness. The two are caused by different stimuli. Motion sickness is generally caused by your body telling you there's motion and your eyes reporting that there's not. So standing on the deck of a ship when it's in high seas, it's rocking around, your body's telling you the floor is moving, and the visual system looks at the horizon and sees the horizon not moving. Conflict of that, and therefore that makes you feel sick. The common leading theory as to why this happens in VR is that the opposite is happening here. We have what's called a sensory conflict, whereas your eyes tell you the environment is moving all around and your body goes, hang on, no, I'm not reporting any of these movements, and therefore is stationary within the environment. Therefore, there is a mismatch between the two, which gets worse when you do things like moving, like with slide locomotion and things like that. It varies from person to person. Some people have more tolerance of this than others. While the method of induction is different, the symptoms are the same, ranging from dizziness, nausea, sweating, up to headaches, and in very extreme cases, vomiting. This doesn't seem to happen as often as it does with seasickness or things like that, mainly because the stimuli isn't as severe and is controllable. You can stop it at any time you want by simply just not moving around within the environment. But these issues are specifically problematic in healthcare because generally we want to make people better, not worse. We don't want to make people sick. But also introducing these symptoms can interfere with a diagnosis you're making. If you're trying to get somebody to relax by using some XR environment to place them in a nice calm environment while you're running some tests on them, if they are becoming sick from having that device on their head, that could introduce a symptom that is misinterpreted, and therefore a misdiagnosis gets made. So does XR have a place in medicine? Well, we have already got some success that's already evident. The CBT therapy stuff is becoming more and more widespread as we go through and is being used in a wide variety of places. And we have a lot of pie in the sky stuff of we want to use XR in medical settings. And there's a lot of pipe dreams as to things that we want to do with this technology. However, the technology isn't quite reliable enough yet. It isn't quite accurate enough. And we still haven't figured out some of the UI conventions that we need to get through at this point. But it's coming. It is going to be a thing probably within the next 10 years. It will probably not be in the same form that it's in because it's such a rapid evolution of the technology. But we're likely to see some form of widespread XR within the next 10 years, in my opinion. So that it's coming. You need to be aware of these things, and you need to be aware that when you're developing your XR systems, you're not just thinking about what information you're conveying to the user, how you're conveying it, and where that information is within the environment, where you're placing it. Okay, so I believe I've overshot by 10 minutes. I do apologize, but that's all I have to talk about. If you have any questions, I'll take them now. I've provided some links to the videos in the presentation, and I will make sure that the presentation is provided to the organizers at some point. So if anybody wants to go back over these things, they can do. If you've got any more issues or you just want to talk about XR or things like that, or you need some advice, my email's there at the top of the page. You can just drop me a line and I'm happy to talk to people about that and things like that. So any questions?
Dear participants, any questions? Please write to the chat.
I cannot see.
No, I address to the participants, to the students. If you want to ask something, please write to the chat. In chat. Just 1 minute. 1 minute more. Okay, dear professor, may I ask one question? I want to ask you, do you have any experience with VR application or VR application with surgery, or do you have this experience, or maybe you have an example of this real surgery, or it is only future of VR technologies?
VR in surgery at the minute, I would suggest that there is probably some prototype studies going on at the minute with it, but it is definitely not a widespread thing because it's, like I say, it's not reliable enough. We don't have enough information about what's going on at the minute. The particular issues with it, with the safety concerns behind it, you would probably start on some minor surgeries with it, though. I can have a look around and try and dig out some research on it this afternoon if you would like, and I'll forward that to the organisers and they can send that to you. But it is not widespread. It is theoretical at the minute.
Thank you very much. Thank you for your participation. Please send the presentation right to me, and
Yes.
I try to upload it to the Moodle because it is very useful. These are very useful links on your final slide.
Mm-hmm.
And thank you one more time. Sorry for the I didn't highlight the time, our local time.
I will also apologize for not turning up on time. I should have actually thought about it. I'm inexperienced in doing the international things at the minute. So I've learned something now. Next time I will check for local times. So thank you very much. I apologize for you being late, and I thank you for your tolerance on the matter.
Thank you and goodbye. And for all other participants, we will meet after the break for the lunch. Thank you. Goodbye.
Cheers. Thank you.
Dear participants, please connect again. Now we have time for lecture from Portugal, Polytechnic Institute of Tomar, and a mobile cross-platform development with Xamarin Forms by Sergio Rodriguez. Sergio, do you hear us? Okay, please wait a few minutes. Dear Sergio,
Hello, Alex.
hear
Good
us?
morning.
Good morning. Good afternoon, actually, in Astrakhan, and good morning. We have
Are you
40.
seeing me now?
Yeah, we have 48 participants right now, and you can start if you are ready.
Okay, let's start.
You can share your presentation.
Yes. First of all, I would like to ask the participants some questions just to be aware of their knowledge. Okay, I'm gonna put here the chat so I can see. And I would like to ask you, maybe you can answer by raising your digital hand on the reactions. Okay, it's better than to write on the chat. I would like to ask you, how many of you have knowledge in object-oriented programming? Can you raise your digital hand, of course?
Or maybe probably write plus in the chat.
As
Yeah.
you wish. Okay.
Данила Хныкин, Виктор Валеев, Яна Задверняк. They have an experience in objective-oriented programming. Object-oriented programming, okay.
Okay.
And I think
So the next question that I had, it's if anyone has experience developing in Xamarin, but if so few people know object-oriented programming, maybe it's no need to make the question. Okay, so I will pass to my presentation. Okay, let me share my screen. Okay, are you seeing the full presentation or the presenter mode? Are you see the full presentation? I can't hear you. Alex, are you hearing me?
Sorry. Now everything good.
You are seeing in the presentation in the presenter mode or the full screen?
No, now we see only your image, only your
I'm gonna share it again.
only your camera.
I'm gonna share it again.
Okay, yes. Right now we see the screen.
Okay. It's
Yeah.
in full
see
mode. It's in full mode.
Full mode.
Okay. Thank you. So let's start. My name is Sergio Rodrigues, and I'm a lecturer at the Institute Polytechnic of Tomar. Okay, and I will be talking in the next minutes about mobile cross-platform development with Xamarin Forms. Okay, this is our campus. You have a 3D visit now on the website if you want. What I will talk in the next minutes are these topics, mainly the .NET architecture, because it's important to understand it before go into Xamarin. Next, the Xamarin Classic and Xamarin Forms, because there are two ways of developing mobile application, two paradigms to develop with Xamarin. Next, we will look at the model view model pattern that supports the mobile development in the .NET. And finally, I would like to develop here live if I have the time. If not, I will show you and I'll show you the app. But if I have the time, I will try to develop here a small app with Xamarin Forms, okay? So the .NET, first of all, is free, okay? It's open source, is owned by the .NET Foundation, supported by Microsoft, of course. It's a development platform, and we can build many different types of apps with the .NET. Web apps, cloud apps, mobile apps, desktop apps, console apps, games. Unity is integrated with the .NET, IoT, machine learning, Windows services, serverless functions in the cloud. So we have many flavors of apps that we can build with the .NET. The .NET shared functionality through class libraries among all of these implementations, and they have the same look and feel across apps. This is important. It's cross-platform because we can run and develop on some of them, or some of the platforms with .NET. So it supports Windows, macOS, Linux, the major 3 operating systems, Android and iOS on mobile, and tvOS and watchOS, okay? And supports also the Intel and ARM architectures, 86 and 40 and 64-bit. The main programming language that the .NET supports are C#, it's a modern object-oriented language, F#, and Visual Basic. I put it here stable because Microsoft doesn't have the intention of develop more this language, so its development. But it's also supported by the .NET. And we have 3 integrated development environments to develop our code. Visual Studio in Windows, of course, Visual Studio Code, that is a lightweight version of Visual Studio, and Visual Studio for Mac. The .NET are a set of libraries and tools for developing and running the .NET applications. And we have, it's composed by two components, the SDKs that we install on development machines where we want to develop our applications, and the runtimes that we install on machines that need to run .NET applications, like, for example, the ASP.NET Core runtime or the .NET runtime. Talking a little bit more about this, the .NET and the runtimes can be installed independently of one another. Okay, like I said, it depends of the profile of the machine that we want to install. The runtimes include only the necessary components needed to run the application. Those components are the runtime libraries that provide primitive data types and essential utilities. We have also the .NET driver. It's a command line input to run framework-dependent applications. We'll talk later about what it is framework-dependent, what it means, framework-dependent apps. And one of the following three runtimes that we can install. The .NET runtime, the basic one, includes only the components to run a console application and provides a type system, assembly loading, garbage collector, and native interoperability, and other services too. The other runtime that you can install, optionally, is the .NET Desktop runtime that provides the .NET runtime that I mentioned before. Okay, we do those components, plus the basic services for Windows desktop apps, including Windows Forms and Windows Presentation Foundation. We have also the ASP.NET Core runtime that provides basic services for web apps, IoT apps, and mobile apps. On the other hand, we have the SDKs for development machines. And the SDKs include mainly a command line tool, as I said, the .NET CLI, the .NET driver. It's a CLI command to run framework-dependent apps. The compiler, the Roslyn compiler for C# and Visual Basic, and an F# compiler. These are the programming languages that are supported, as I said before. Also, it includes a build engine, MES build, and all the components and runtimes that I detailed before. The runtime libraries, the .NET driver, the .NET runtime, the .NET desktop runtime, and ASP.NET Core runtime. All the runtimes come with the SDK. Let's talk about a little bit about the .NET implementations. There are 4 implementations supported by Microsoft, and they are these ones that are displayed. Let me put the laser here. That are the ones that are displayed in the slide now. The .NET Framework, Mono, Universal Windows Presentation, and the .NET 5. The .NET Framework is the original implementation of the .NET since 2002. Okay, and Mono is an open source implementation of the .NET framework to create cross-platform applications. So we can create applications in Windows, not only in Windows, but also in macOS or in Linux. Then the Universal Windows platform, that is an option to create client applications for Windows, targeting many different devices from desktop to Xbox game console, or even mobile. last but not the least, and I put here in bold, is the .NET 5, because it's now the primary implementation being developed. And the .NET 5 is a cross-platform implementation, and it's built on a single code. This is important. This is a great effort that Microsoft is making to build all this framework on a single code. It unifies a set of features and APIs that support many workloads like Windows desktop apps, cross-platform apps, console apps, cloud service, and websites, as I said before. All these implementations share a common API that's called the .NET standard. In fact, the .NET standard is not only an API, but a set of APIs that are implemented in the base class library of each implementation. Most important of all is that the .NET standard is a target framework. This means if the code targets a specific version of the .NET standard, then it can run on any .NET implementation that supports that version. That's why this is important. The .NET standard was created to enable portability across different .NET implementations, but now the new .NET 5 is assuming that role, and much better. That does maintain backward compatibility with all .NET standard versions. So this is a very important common API. We will see it a little bit later on. And now let's talk a little bit about the components of these .NET implementations. Its implementation of the .NET includes multiple components. You can see them on the right. One or more runtimes. For example, the .NET Framework Common Language Runtime, or the .NET 5 Common Language Runtime. Includes also a class library. For example, the .NET Framework base class library, or the .NET 5 base class library. So you see each of the implementations replicate these components. Optionally, also includes one or more application framework, like, for example, ASP.NET, Windows Forms, or Windows Presentation Foundation, that are included in both .NET Framework and .NET 5. And optionally, it also includes development tools. This table, I don't go much in further detail about all these versions, but simply saying what it shows us is that the compatibility between the implementations version and the .NET version. Let's say it's important to emphasize that the .NET standard versions are cumulative. Meaning that if an implementation supports, for example, the .NET standard 1.5, then also supports all the previous versions from 1 to 1.5. There are no breaking changes between versions, okay? They are also immutable, meaning that they are frozen after they have been shipped. This is very important to developers. So if you want that your application, your app targets more than one platform, you must choose the smaller version among them. And this is for what this table is important. For example, imagine that you want that your app run on Mono version 4.6 and in .NET 5 here in the first line of the table. So we go to Mono line, and you can see that the 4.6, okay, we go and running through the in order in extend order of the .NET standard versions, we see that the last version of the .NET standard that the Mono 4.6 supports, it's 1.6, okay? No higher versions Mono 4.6 is supported by Mono 4.6. So we must choose 1.6 that is also supported by .NET 5, okay? This is the way that we can extract from the table to see which .NET standard version we must choose for our app. So when we need to choose which .NET standard to target, we must consider also a trade-off between choosing higher version possible, so we have more APIs available, and choosing the lower version, so more apps and libraries can use our library, okay? It's a trade-off that we must have in choosing the .NET standard to target. The rule of thumb here is to choose the lowest version possible using the following methods. First, we find the highest version possible, and then we use the next lower version and try to compile our project with it. In the example that I give, we have the .NET standard 1.6, so we will try to compile our app with the 1.5 version of the .NET standard. If our project builds without errors, okay, we can repeat the step. Otherwise, we retarget to the next higher version. Okay, so we will try it with .NET 2, and in this example, we will get errors. So we will decrease the version to supported 1.6. Okay. One final alert just about the .NET standard regarding that there will be no new .NET standard versions after 2.1, okay? Because all the APIs supported by the .NET standard are now ported to .NET 5, okay? This is just for backward compatibility reasons. Well, a picture is better than 1,000 words, as they say. So let's look here at the architecture of the .NET, the past architecture, okay? And as you can see here, and as I talked earlier, we have the implementation .NET framework here in green, okay, with the app models, Windows Presentation Foundation, Windows Forms, ASP.NET for the web. We have also the implementation, the .NET Core, okay, and this goes to the .NET Core 3.1, okay, with its application models, Universal Windows Platform, and the ASP.NET Core. And the mobile implementation in Xamarin, okay, for iOS and Android and macOS. We have the .NET library as a layer below, as I spoke before. The this library and this set of APIs that is common to all these implementation. And in the lower layer, we have the common infrastructure, the compilers, the language, C#, F#, and Visual Basic, and the runtime components. Now, the architecture is much more clean, as you can see here. We have the .NET 5 layer here, common to all the app models. You can see that these app models are extended to gaming with Unity, to IoT in ARM 32 and 64-bit, okay, into artificial intelligence implemented in machine learning.NET and .NET for Apache Spark. In the lower layer, we continue to have the infrastructure, the runtime, the compilers, and the languages. Okay, so this is a much more clean architecture, as I said, and is the reality right now to develop cross-platform applications with a unified platform supporting it. And we have, of course, for all these, the tools that I mentioned before, the Visual Studio for Mac, Visual Studio Code, and a command line interface, of course. Here we can see in this table some compatibility between the .NET Plus, the next version of that .NET, that is the 6th, that will be released in the end of this year. We can see, for example, the .NET 5 now has compatibility with the .NET 1 to 4, with .NET Core App 1 to 3.1, as I said before also, and with the .NET Standard 1 to 2.1, of course. The .NET 6 will be the subsequent version of the .NET 5.0, and will bring everything that the .NET 5.0 have now. It will inherit and will address also the Xamarin Android, Xamarin iOS, Xamarin Mac, Xamarin iOS, and Xamarin tvOS, and the .NET 6 Windows. This slide shows us how an application can be platform agnostic, developed with the .NET, okay? And I will show you, well, now I'm gonna make a little demo, okay? I will open my terminal here. Okay, can you see the terminal?
Yes, we see.
Okay. Okay, I'm in the site now. I'm gonna show you the portability between different platforms for the .NET, mainly what I have been talking about a few minutes ago. So let's make here a directory. Okay, I have nothing here. Let's see what I have installed in my machine. I don't know if the letter is too small, or you can see it okay.
Everything okay?
That's okay. See, I have the .NET version 5.0302. I have another platforms here. I have also, sorry, a Windows machine.
And Ubuntu.
And I have the same version of the .NET installed. And I have also a Linux machine.
Mm-hmm.
With the same, it's the last one, the same .NET version, okay?
It works.
Now, let's return to Mac, and I will make a small application. In console mode, of course. Oh. Sorry about that. Live is always dangerous. Okay.
Oh, it works.
Yes, it works. Okay. We have here our application. We have, of course, a simple program. Let's see it. Yes. Okay. It's only right in the, it's a default generated code. It writes hello world in the console. Okay. And nothing more than that. Okay. Let's run it. Okay. Where are you? Sorry. Not. It's running now. I was in the wrong directory to run it. Okay, it couldn't find the project. So you see it right on the console, the string hello world. We can go now to debug net 0. Okay, and you can see here that our application it's named hello world.ddl. Okay, this is a executable file. Nevertheless, it's being a dynamic link library. The reason is since no other compilation option was defined by me when I compiled the application was created as a framework-dependent application. That means that I need the framework installed on my machine, okay? But if you are talking in the .NET framework context prior to the .NET Core, this would strictly refer to the Windows platform, this being framework dependent, okay? In this context, it means that the application is only dependent on the framework itself while being platform agnostic. I will show you this agnosticity now, and I will transport this code from the Mac machine to the Windows machine, okay? Let me open here a new folder, Windows, and go to where I created this. Here we have the Hello World project, and let me open also here. Okay, I'm gonna copy. I don't need it, just the bin. Okay, let's copy on this folder to the Windows machine, okay? And I go to terminal right now. I already have here the bin folder. Okay. The net 5. Oh, sorry. Okay, I have here my executable also, the LOO, the DLL, okay, and let's see if I can run it. Or if I have to, I have to copy all the project, sorry. Let's do the project directory. I have my project here. And as you're gonna see now, I will not compile my application. I will only run it, okay, with the .NET driver, run. Okay, it takes a little bit. And voila, hello world. So this shows our agnosticism. I can do the same thing. I can do the same thing in Linux just to prove it. I'm gonna copy it here. Oops, sorry. And copy my project. Let's see the projects. And yes, okay. I think it doesn't copy it now. Why not? Okay, there it is. Okay, cd hello and .NET run. Oops. Hello world again. Okay, so we saw that our platform that was compiled, that our code that was compiled in one platform, it runs on another platform. This shows our the agnosticism of the .NET. Okay, I will return now. I don't need no more of these virtual machines. So I'm gonna close them because, as you imagine, this is a lot of load on my machine. So let's make it lighter. And let's return to our presentation. Okay. You are still seeing the presentation? Alex?
Yeah, we see.
Okay, thank you. Well, what we have just witnessed can be represented this way. Here, the infrastructure is provided by the target platform, and the UI, you can see the target platform. Sorry, it should have here macOS and here Windows. Okay, the macOS vanished. I don't know why. The target platform provides the target, the infrastructure is provided by the target platform, and the UI, the user interface, okay, and the application are portable across platforms, as I showed you before. The two operating systems have the .NET runtime installed, of course. If not, I couldn't run the application. And the implementation of the .NET standard by the base class library allows us to run the same binary package on both platforms. This is very interesting because we can develop our application and compile it on the platform that we have at our disposition, and then just port it to other target platforms. Okay, so this slide shows the platform agnosticity of a .NET application. The .NET application has a dependence on the .NET Core app runtime, but it's also possible to generate a self-contained package, because as I showed you, the output of the compilation executable was a dynamic link library and not an exe file. Okay, but we can generate a self-contained package so that if the target system doesn't have the .NET Core runtime or the SDK that have also the .NET Core runtime, it's still possible to run the application. Okay. Another important aspect is that the framework definition. While using the .NET 5 as the target framework, could be sufficient for the console application, as you saw before, for a Xamarin or a Universal Windows Platform application. That may not be sufficient. Eventually, we need to use the .NET standard and a specific target for the infrastructure, such as Xamarin iOS, for example, and this can be done through the target framework tag that is in the project file. Okay. I can show you maybe here. Where is it? Okay, get CS project. Okay, as you can see here in the project file, that the hello world CS project with the extension CS project, you can see that the tag target framework, and we are saying to the compiler to compile with the .NET 5 with the .NET 5. Okay, we are starting this framework. Okay, but we could have been target other platforms. I will show you. I will show you here. So there are monikers for the various implementations of the .NET. For example, for the .NET Standard 2.1, the moniker is Net Standard 2.1. For the .NET 5 and .NET Core, of course, you have the .NET 5 and .NET Core App 3.1. It's the last version developed before it jumped to .NET 5. Okay, for the .NET framework, it's .NET 4.2. It's the last version also. And for the Universal Windows Platform, we have UAP 10. Okay, these are the monikers that we can use here in the tag framework in the .NET project file. Okay. This in this slide, I must show you before the other is really the agnostic deployment. Okay, as we've seen it in the different operating systems. Okay, and then if you want to develop targeting specific platform, as I showed in the last table, the monikers for each of them. Okay, you could do it so, and so the application will take with it the .NET runtime here in blue. Okay, it will run also. Okay, Alex, tell me, we have only 1 hour, right?
No problem if you want to take more time. It isn't problem.
Okay, nice, because a bit a little late. Okay, I will try to accelerate. Okay, so let's get into Xamarin. In Xamarin paradigm, we have 2 ways to develop our mobile applications. And these 2 ways are what is called the Xamarin Classic, okay, versus the Xamarin Forms. Let me say, you have here a call, and below is an important note. Starting in November this year, Xamarin iOS and Xamarin Android, the classic Xamarin, will become part of the .NET 6, okay? They will vanish and will become part of the .NET 6 as the .NET for iOS and the .NET for Android, okay? Also, the Xamarin forms will be substituted by the MAUI, the .NET multi-platform app UI. This is, I emphasize this because if you will go into this world of the .NET, it's important to know that these implementations will be substituted soon in the end of the year. Okay, so we have 2 different approaches. The Xamarin Classic, let me put here the laser pointer, the Xamarin Classic on the left and Xamarin Forms on the right. And you can ask, why have we these 2 approaches? Well, they are a little bit different because with Xamarin Forms, there is an intermediate layer that separates the specifics of the operating system, iOS and Android. So Xamarin Classic is fully native. And with the fully native, we can have greater performances. Okay, if you want to have the richness of the UI of iOS or Android, and you want to have also the best performance possible, okay, and the better integration with platform specific, so you must develop with this approach, Xamarin Classic, Xamarin iOS, or Xamarin Android. Let me say that these, despite these different approaches, you don't have to duplicate your code, like if you are developing in Xcode or Android Studio, okay? You have one code only, and then you have projects for iOS and Android where you will implement the specificities of the operating systems, okay? Well, Xamarin Forms is a little bit different, as I said, because it have an intermediate layer, and the UI is shared for all platforms, okay? We only code one UI in XML, and it's the same for all platforms. It have more shared backend code, okay? It's best for consumer-oriented apps that doesn't require so rich UI or so greater performance, and it's best for cloud-connected apps, okay? But before we dive into Xamarin, I would like to talk you a little bit about the patterns that support the mobile development in Xamarin Forms. okay? Because that's important to understand their function. I don't know if you are aware of the pattern, some patterns in object-oriented programming, but the MVC, the Model View Controller, is a popular one, and this model is an architectural pattern that separates an application into model, view, and controller, as we can see here. The view here is responsible for the presentation of data to the user. The model that we have here is responsible for maintaining data and its business-related logic. And the controller, it controls the interactions between the model and the view component. This is interesting because it permits to separate the view or the user interface, if you want, from our model. Okay, so it's get better maintenance. While the MVC is being used widely with the web applications, it born with the web applications. Generally, a derived version of this pattern is used for mobile and desktop applications, the MVA. Okay, the MVA, or Model View Adapter, or sometimes called the Mediated Controller, MVC also. In this architecture, the adapter here, acts as a mediator between the view and the model. Okay, let's see here. Okay, the view gets data in the MVC, gets data from the model, and the model notify the view about changes that occur in the model. Okay, and the controller update the model. Here, and the Model View Adapter, the controller is a mediator between the view and the model. So the controller updates the view when is notified by the model, okay, that has been changed. And then the controller can bring also the data from the view and manipulates the model. But this has a drawback, this pattern has a drawback, that is the view is tightly coupled to the controller, okay? And in object-oriented programming, coupling, normally it isn't good. Okay, so Microsoft came with a new model for developing mobile applications that it's called the Model View Adapter, or Mediating Controller. Okay, sorry, I'm sorry. This is wrong. It's this is wrong. Sorry.
Is everything okay?
It's okay.
Mm-hmm.
Okay. So Microsoft come with this version of the MVC. It's called the MVVC, or Model View Model. Okay. Despite all the benefits of the other pattern, okay, or derivative, the MVA pattern, both have the disadvantage, as I said to you, the tightly coupled between the controller and the view components. To resolve this drawback, okay, Microsoft introduced this new pattern back in 2006, okay? And once more, the fundamental idea of this pattern is to separate the three layers of the code: data, business logic, and the presentation. This way, the MVVC offers the separation between the user interface. This is the view from the development of the business logic. We have here the view and here the view model. Okay. Of the business logic or the backend logic, that is the model resulting in the independence of the view from any specific model platform. Sorry, it passed. In this new pattern, the control role is now played by the view model component, and the coupling between the controller and the view components is calling binding. Okay, it's a different approach. So in this pattern, the MVVM, okay, as a binder for automating and replacing the two-way communication between the two components. Okay, see, this is the MVA. It's a little bit different. We have tightly coupling here between the view and the controller, and that coupling is now lighter, okay, by this other approach that's making a binding between the view model and the view. Okay, the coupling between the model and the view model, it stays the same, okay, but it's a lighter pattern in terms of performance. Well, now the time that I would like to go live to show you developing a small application. Okay, I will not have the time to develop it from the beginning as I thought, but I will open the application, okay, and I will speak a little about some things that may be important in developing the application. Okay. So maybe 15 minutes more or 20 minutes more. Can I, Alex?
Yes, yes, you can, because right after you, we have a final section of our summer school, closing of the summer school, summing up the results, and you can spend 50 minutes if you want.
Okay. Let me close my my Windows virtual machine, okay, because developing and opening the mobile simulators, Android and iOS at the same time can be a very exigent task. Okay, so let's free some resources here. I don't need no more of the Windows virtual machine. In the last slide, I have some books and the sites from Microsoft that you can explore. Sorry, that you can explore, and all these examples are taken from this bibliography and webography if you want to explore them later. Okay, I think you will. I will send you this presentation. That's true, Alex?
Yes, you can send it to me, and I will upload it to Moodle system.
Okay, nice. So the students can have access to this bibliography. Okay, I think the machine went away. So I will not develop this from scratch, but I'm gonna just open here. This is Visual Studio for Mac, okay, 2009. I will open here the beginning to making a new project, just to emphasize what I said before. You can see here on the templates, the iOS the templates for the iOS platform, the classic Xamarin, as I told you before. Okay, you have many templates for all types of projects. You have the template for developing a single application or a master detail or a tabbed application or a page-based application in iOS, for example. In Android, you have different templates because they are different operating systems, blank app, bottom navigation app, okay? And these are the classic Xamarin development templates. If you want to develop in Xamarin Forms, it's what I will gonna show you, okay? You can show one of these three templates: blank app, flyout app, and tabbed app, okay? You can also target your code to be dynamic linked library, shared or portable. There are slightly differences, okay? And also templates for tests. So if we choose our blank app and make next, we have here a screen where we are asked for an app name and what are the target platforms that we want to develop our project. Let's say we want Android and iOS. Okay, then you must choose the project name and the solution name. The solution here in the Visual Studio is basic how can I say, a drawer where you have all your projects, okay? It's just an organizational way of having your projects. You can choose a location, let's say here, MAGnUS, MAGnUS Summer School, okay, presentation, for example, open, okay. Now we can create it. Okay. And now we have here Visual Studio, okay, with 3 projects. Here we have the iOS project, okay, with its structure, okay. Here we have the Android project. You can ask why this is in bold and test iOS is not in bold, because this is the bold means that the Android, it's the active project. So if I compile my project, it will compile for the Android platform. See, if I want to be to the iOS platform, I can change it and it will be for the iOS platform. And we have also here another project. This test project is a .NET library project, okay? It's here in this project that will develop our backend code. Almost 100% of the code will be here. Only specific things of the platforms for Android and iOS will be in each one of their projects, okay? So I will leave now this test application. It was just only to show you how to create a new Xamarin .forms project, okay? And I will open a project that is already done, where I have that demo here, okay? Let me show this one. Because the difference of these save points in the project are that the basic ones, it just only implements the model and the views, and then the multi-page we have in the multi-page project we have multi-page, and in the MVVM I made some refactoring in the application, so to introduce the MVVM pattern, but I will not show you this. I think I will show you first these basics and what was coded in here. So in here, first of all, we have created two new folders in the project, the models and the views folders, to have these components organized in my project, okay? In the view, you can see, also I deleted the generated main page because it doesn't have interest to this project, and I create a new one. When I create a new page in forms, I can create many types of page, but one of them, and the most common, is this forms content page XML, because in developing with Xamarin, we have the front end, that is the UI, okay, in XML format. This is XML specifics for Microsoft, okay, and it is a marked language, as you can see here, with all its text, and in this this will produce the UI, as I said. Let me state that these XAML pages are always have always company of a code behind page that is purely C# or F# code. Okay, so here it is C#. I choose C# for this project. Okay, and we can see that this page have exactly the same name, main page .xaml, and the C# as the extension .cs. Okay, so if you can see here, we have this partial class main page. The partial, it means that this class is spread through different files. Okay, the main page XML and the main page XML.cs. Okay, maybe I can run this and to open the simulators. Okay. First, I will run for Android. Okay, I have created a simulator. I am gonna not enter into details how you can create this simulator, but here at the tools menu of the Visual Studio, you have device manager and the SDK manager. So you can install here at the SDK manager all the SDKs that all the flavors that you want for the Android. I choose, I think the last version, it's the version R, and created here in the device manager, created some simulators for that version. For example, this Pixel 2 that targets the 11th version API 18 of Android, okay? So if I run it, well, this takes a little bit, and the Android simulator, it will open now. It takes some time. Okay. Let's put in here. I think I can put it smaller so we can have the iOS simulator too. Okay. It's compiling now. And deploying, I hope. Oh, my emulator is out of date. It was running yesterday. Oh God. Okay, no problem. It's running. So what we have here, it's a page. So this main XML UI just displays a collection view. Here at Xamarin, the controls are called views, okay? So we have here a collection view with some lines that I hard-coded here in this, I wired to that collection view with a list of places, okay? We have them here and they are presented in the application. So when here is the basic one, it doesn't do anything. It's just displaying the items from the list, okay? So this is the basics for displaying, for example, a collection, a page with a collection of items in Xamarin Forms. Okay, I will open now. Let me show. I can show you in the other version of the project, and open the simulator there. Let's close this one and open here the multi-pages. The same project, but with a little more code and more pages. And I will now compile for iOS and open the iOS simulator, the iPhone simulator. Okay, let's choose, for example, iPhone 8. And let's compile our application. Okay, you can see here in the Explorer that I not only have the main page, but I created also a detailed page, okay, where I will show a map and a new entry page when we can enter new items for our collection. So let's compile it, and it will open the simulator. Maybe this simulator, it takes a little bit to open. Waiting for the debugger to connect to the iOS simulator. So the main advantage here, as you already have understand and see it, is that we develop our code one time, okay, just one time, and then we can deploy it for the Android platform or the iOS platform. This is most comfortable and it reduces our development time. Of course, we don't have here the best performance. As I said to you, if you want the best performance for your application, you must choose the classic Xamarin in develop for Android and for iOS. There, your code, it's not so you can not share as many code as you can share here at Xamarin Form. So this is a compromise between performance and the time used to develop your application. Okay. Well, it's taking a little bit. Okay, it's here on my other monitor already. Okay, so see, we have just one UI code for the two operating systems. We don't have the need, as in classic Xamarin, to code a different UI for each operating system. Okay, this is a great feature that we can use in Xamarin Forms. So if I take here if I click on one of these items, okay, it navigates to another page. This is this detailed page here, okay, and in this detailed page I have a map. Okay, this is integrated with the Xamarin forms.map, okay, that provides the API to connect to Google services. Okay, we can see here that it goes to the coordinates that are here in our collection. Okay, if I go, for example, for the Astrakhan State University, okay, it's there. Okay, do you recognize it, Alex?
Yes, yes.
Okay, it's that. So more things that I can. Okay, this it's not important, but for this application it's important. The integration with the Google API, it's made here at the Android manifest, okay, for the Android project. For the iOS it's automatic, but in the Android you must do something more. Let me open this with the source editor, okay, and you can see here that I have this metadata Android, okay, and we target the Google Android maps, and I have here a key. This key I created in the Google platform so that my application could connect to the Google API, okay? So this is a simple application. We have, of course, another page here, as I mentioned, this new entry page, also with a front end. This front end, it have a table, and in this table, I have multiple entry cells, okay, with their labels, and I can enter data in here. So if I click here in the new button, it will navigate to this new entry page, okay, and we can write here something, okay. This is in this save point of the version. The save button isn't functioning yet, but is to intend that when we save the new place, okay, it will appear automatically here at the first page. Let me close now this, okay, just to talk very little about the MVVC implementation. And 5 minutes, I take only 5 minutes because I think you are tired. It's the end of the day for you and the end of the summer school, right? So let me close this and open now another one. Okay. So I just want to show you here some refactoring of the code. Here we created another component that I told you in the MVVM model, the model view model. Okay, here we have the view models. Basically, this is the controller that will mediate. Here it's not better to speak in mediating, because the true thing that happens between the views and the view model is that we have binding, okay? Binding is a property, it is a way of we program our properties in the view model. So when a change occurs in the model, okay, the UI is changed by the view models, and also the other way, when we change our UI, okay, the view models is notified, is binding to the view, so it goes to the model and updates the model. So it's a two binding model. Here we have made some refactoring, and you can see here that my base view model now implements, okay, this interface, the iNotify property change, that is the core of the binding between the UI and the sorry, the UI and the view model. Okay, this is implemented here. The interface, it only have this event on property changed, okay, and it's implemented here. So we can have the two-way binding. Then I refactoring a little here, and in my main view model, I put it here the list that will link to our collection. As you can say, it's the same list, okay? And now our log entries, our observable collection of type place entry, okay? This place entry is a class that have all these properties: title, notes, rating, date, latitude, and longitude. Okay, but now we don't have a list, but an observable collection. Okay, and this observable collection, observable collection, is it will be linked, if we can see it here. For example, the XML UI was refactored, so our, let me open this a little bit. Okay, as you can see here, our labels were refactored and using binding. Okay, and that's all I needed to put here at my UI. So now I have my user interface binded to my view models. Okay, I didn't say it, but this main page, I don't see if you have seen it. This main page inherit from base view model, the one that we created where we implemented the iNotified property change interface. Okay, so I ended my presentation. Sorry, I have intended to do all these live, but the time passes too quickly. And nevertheless, I think I can give to you some insights developing in Xamarin Forms. Okay, you can.
Everything was interesting. Everything was interesting, and it is really useful for creating applications, mobile applications.
Okay, спасибо, Alex.
Спасибо большое.
It's the
Thank you
only
very
word
much.
I know
Thank
in
you.
Russian. Forgive me.
Dear participants, dear students, probably you have a questions. Oh, one comment from Danilo Khnikin. Thank you very much for the presentation. So interesting. Any questions? Any comments? Notes?
They are tired now.
I think so. But oh yeah, one question from Rastam Aminov. Which framework is the best in 2021 for Android development? How do you think?
Now the stable framework is .NET 5.0. Okay, it's the stable one.
Probably Rastam means what else? Not only .NET, probably something else.
Oh, he's speaking about the tools for developing mobile applications. Well, I'm not a Microsoft employee, so I will not defend this approach by .NET. You have many flavors of tools, or you have many tools to develop mobile applications, okay? From multiple fabricants, IBM as one, okay? We have an enterprise in Portugal that is OutSystem. It's a wide-known enterprise that develops, that have a tool for develop mobile applications. It's a visual tool. It's a very good tool. It have the same approach that Xamarin have, so you can develop one-time code and then deploy it for each of the two platforms, Android or iOS. Okay, it's a visual tool. It reduces very much the coding time. Okay, you have also Cordoba, but what I think it's important here to refer, it's when you choose one of these tools, you must have in mind what you want your app for. Okay, if you want the best performance, you must choose a native development, or you choose Xcode to develop for iOS, or you choose Android Studio to develop with Java, Kotlin to develop to Android, or you can choose Xamarin Classic, okay, or you can choose another tool that implements native applications. Okay, if you want all the richness of the application, of the specifics of the operating system, okay, so you must choose Xamarin Classic or these specifics. If you don't want it, if you want to connect to the cloud, if you want a consumer application, okay, you can choose, for example, Xamarin Forms. Okay, if you don't are worried with performance, maybe you can choose encapsulated browser like Cordova, okay, developing in Cordova. So you must have aware, you must be aware of the objective of your application to choose what to develop your application. Okay, but Xamarin, it's really a good system. It's now being mature. Okay, as you've seen it by the architecture. Okay, it's open source. That is important because the pace that the .NET is evaluating is now much quicker, because there are many people in the world developing for importing the .NET to .NET 5, okay, and .NET 6 being open, and this was a major step by Microsoft. Being an open platform, it's very important nowadays, okay, and they made it, and I think they gain with it. Okay, I hope to have a response to an answer to your question.
Rastam, thank you very much. Very interesting, Rastam says. Thank you, dear Professor Sergio. Thank you for your participation. And now we have a time for closing the summer school.
Can I leave now, Alex? Sorry.
What?
Can I leave now?
Yeah, you can leave. If you want, you can stay and hear the results of summer school as you want.
Okay, I'm gonna leave. I'm gonna lunch now.
Okay. Okay.
So
okay.
possible.
Yeah, you have a lunch time. Yeah, you have a lunch. Yes.
Okay.
Really, the difference between times. Thank you very much. Goodbye.
See you next time.
Goodbye.
Thank you once again.
See you. Goodbye.
Bye-bye.
You need to switch off. Yeah, okay. Dear participants, now we try to summarize the results of our summer school, and I want to show you the small presentation about our results, and I think you may say what you want to say, what you think about our summer school. Probably you can write in the chat what is most interesting, or what is interesting for you, what was interesting for you. Please write in chat, and I try to show you small presentation with the results. Dear participants, you may see the presentation about the results of the summer school. And our school was from July 20 to July 27. It was 7 days, and 16 teachers from 7 universities have took a part in our MAGnUS summer school. And as we calculating now, and I think we try to calculate, we will try to calculate it after a few days one more time. You may see these statistics from 27, from July 27. On our Zoom platform was 64 maximum number of participants, and about 15 participants on the average. On YouTube platform, on YouTube was 154 maximum and about 80 views on the average. On Moodle system were registered 161 users with 155 students in total, and now we see that 51 there are 51 active students here on the Moodle system, Moodle platform. And what else? You may see these are links on YouTube. You can press on these links and go right to the YouTube where we try to record all lessons, all lectures, all workshops, and you can see it one more time. And our teachers and our partners was from different universities, just from different universities of all world, from South Federal University, Voronezh State University, Baku Engineering University, and Azerbaijan State Oil and Industry University, Polytechnic Institute of Tamar, University of Derby, Linköping University, you may see Tallinn University. You may see a lot of teachers from different universities and different countries. Thanks to our teachers and our partners for this possibility to welcome summer school here in Astrakhan State University. And as I said you before, small picture with our faces. We are together despite the distances, and I think I hope that we can meet not only in Zoom platform, but in reality, non-virtual reality, but in reality in our university, Astrakhan State University. Thank you very much for all. And if you want to say something, you can do it, please, or please send a message using chat. And I will read your messages. Okay, okay. Our active participant, Danilo Khnikin, thank you very much for your questions. Thank you very much for your participation. And Danilo Khnikin write us, thank you so much for organizing such an interesting summer event. A very diverse selection of lectures and topics of speeches. Also, I liked the interactive work with the Moodle system. Thank you for the time spent usefully, and in particular to you. Thank you very much for being with us all these days. Thank you. Someone else, please write to the chat. Thanks, Rastam Aminov. Thanks for all lectors and organizers. Thank you, Rastam, too, for your participation. Who else? Probably teachers, probably participants from other countries. You can write in Russian, for example. No problem. Okay, okay. Thank you very much to all of you for your participation. And I think you will continue to develop yourself applications or games, and I hope that this summer school was very useful for you. Thank you very much for all. Goodbye. One more message from Andrei Koval. Thank you, organizers, lecturers, and students. See you in cyberspace. See you, Andrei. Thank you.